Hello, and welcome back on your mathematical journey. So today we're going to take a little bit more of a look at factoring, and this is the part of factoring that I think most students come to dread, right? This is when we have to factor our trinomials that look like ax squared plus bx plus c. Well, hopefully I can spell out an algorithm here that'll make your life a little bit easier in those regards. So let's take a look at it. Right, so first, what do I mean by this setup? Well, what I mean is that A, B, and C are not in fact going to be variables, but rather they're going to be numbers in these spots. So we'll walk through an example, right? Let's look at this polynomial here, right? X squared minus 9x plus 20. So if we were to go ahead and map sort of what is A, what is B, and what is C, right? We'll go backwards. Right, C, right, in this case is just going to be this number here, 20. B is just going to be, right, in this case, notice that it is since plus B, and we have a minus 9x. B in this case is actually going to be minus 9, or negative 9. And then lastly, right, notice that x squared, well, there's no number out front. But this is where I'll offer the friendly reminder, right, that we can always put a placeholder 1 here, right? 1x squared is the same as x squared. So in this case, A is going to be 1. So when we're trying to factor this trinomial, right, the thing I like to do once we've made note of what A, B, and C are, is I like to use a little chart like this. The shape here doesn't matter. What sort of matters is that we have 4 kind of compartments to put information. The compartment on the top, again, the orientation doesn't matter too much. This is just how I've learned it, right? Is we're going to write the quantity A times C, right? Now notice here, A is 1 and C is 20. So 1 times 20 is just 20. And then down here, we're going to write just the quantity B. Right? In this case, it is going to be minus 9. Now, the critical step in this algorithm is we now want to find 2 numbers that multiply together to give us positive 20 and add up to minus 9. Or more generally speaking, for the algorithm, we're looking for 2 integers that multiply to the quantity A times C that add up to the quantity B. So I'll give you a moment to think about it. So what would 2 numbers, 2 integers, right, positive or negative, that would multiply to 20 and add to negative 9? So if you've given it a thought, right, those 2 numbers, right, in no particular order are going to be minus 4 and minus 5. Right? If you were stuck, right, let's say you thought of negative 2 and negative 10, you noticed that they added up to negative 12. A word of suggestion is, first of all, be comfortable with all of your factors, but also in the case where this is a positive number here, right, we're going to either look for 2 positive integers or 2 negative integers, right? That's the only way we get 2 numbers that multiply to a positive integer. Right, in this case, since it's minus 9, we know they're both going to be negative. And then if we need the sum to get smaller, in that case, we need the factors to, generally speaking, be closer together. Whereas if we need the sum to be larger than the one that we're producing, we need the integers to be further apart, right? To illustrate that, minus 1 times minus 20 would produce a sum of negative 21. Right, minus 2 and minus 10 would produce a sum of minus 12. So notice that the 2 closest together factors produce the smallest sum. So once we have these 2 numbers, in the case where A is 1, right, in this case, we're actually most of the way there, because in that case, the factoring is just going to look as follows, right? We're going to put a binomial here. I'm going to put an x in each spot here, right? Because notice that x times x will give us x squared. And we can actually just go ahead and write in each of these integers in one of these spots. Again, the order does not matter. So I'll go ahead and write a minus 4 here and a minus 5 here. So, right, we can double check, right? X times x is x squared. x times negative 5, right, is minus 5x. Negative 4 times x will give us minus 4x. And lastly, negative 4 times negative 5 will give us plus 20. Right, and then the last step to combine the like terms, right? Negative 5x minus 4x will give us a minus 9x. And then sure enough, right, x squared minus 9x plus 20 was our desired polynomial. So this gave us a chance to look at how this algorithm works. In the next video, I'll go ahead and look at how this looks a little more complicated when a ends up not being 1. Anyway, if you have any further questions, comments, or concerns, either about the algorithm setup or in the case where a specifically is 1, feel free to list them below. Otherwise, happy mathing and have a good day.